All right. So now we have to find the intervals on which the function is concave up or concave down. We begin with the domain of the original function, which will look like this on the number line. We've already seen this. And we know that we want to apply these rules, so I have to first find the second derivative of the function. This is the first one, so the second one will be negative 1 over x squared plus 2 over x cubed. Now I want to find the zeros of this function, so I have to solve this equation. When it equals 0. First, I factor out 1 over x cubed, so the second factor will be negative x plus 2, it equals 0, and from this it's clear that the zeros of this function will be 2, which will be here in the domain. Okay. Now we make our table like this. Here will be the second derivative, here the original function. And we've already seen that at 2, the second derivative will be 0, and what we check now is the signs of the second derivative before and after 2, and for this we have to come back to this form. We've already seen that in the domain we only have positive values, which means that the first factor will also always be positive. So to find the sign, we have to check the sign of this function, and for this we have to draw the graph of it. Which will look like this. And we can see that before 2 it will be positive, after it will be negative. So here in the table, here we have positive values, and here in this interval we have negative values. Based on this rule, we know that in this domain, on this interval, the function, the original function, will be concave up, and here, since it's negative, it will be concave down. Okay. Though it wasn't a question, we can see that the concavity of the original function is different before and after 2, so we know that we have an inflection point here.